Welcome to today's session of the 2020 Educators Ag Institute Virtual Hydroponics. We are very happy to have you joining us this afternoon. I'm Cassidy. I'll be your MC for today. We have some housekeeping to do. First of all, if you have not already taken the pre-test, please do so. It is in the little chat box. You can go press the link to it. It is required as part of the Act 48 hours, if you would like those, to do both the pre-test and the post-test for the session. The post-test will also be in the chat box, and you'll get a little pop-up at the end of the session, and tomorrow you'll get an email. So please also complete that. So the chat box is on the bottom part of your screen. You can use it to talk to the rest of the attendees or to the panelists, who are the people behind the scenes. If you want to say something to everyone, please make sure that it is set to go to panelists and attendees. Otherwise, everyone may not be able to see that. Also be sure the chat box is public. Please be respectful. There is a Q&A button, so if you would like to ask a question to our presenter, you can type it in there, and at various points, we will go ahead and answer some of your questions. We'll try to get through as many as we can. We'll be doing a drawing for a gift card to the American Farm Bureau and National Ag in the Classroom online stores. There's some resources that you can use in your classroom there, and you will receive one entry for each session that you attend and complete the pre and post test for. We would like to thank our sponsors. You can see them on our screen, and they really help to make these sessions possible. So this afternoon's session is Hydroponics with Nicole Geiss. She is an intern at the Pennsylvania Friends of Agriculture Foundation, and she is also an ag educator. So let's welcome Nicole for Hydroponics.
Thank you, Cassidy. I'm going to start sharing my screen here. If you joined us this morning, thanks for coming back. And if this is your first time with us today, we're glad you're here. All right, so this should be my PowerPoint. And today we're going to talk about hydroponics. I want to start first with some things that I think will be helpful for you during this session. So if you see this red flag icon, that means that's a shared resource. So I have put together a document that Cassidy will be sending out tomorrow. And so if you see a link or this flag, there isn't a need to scramble to write the link down because it's coming out tomorrow. So we've made that available to you. Secondly, the session is very interactive, so don't be afraid to chat, ask a question. I'll be using Poll Everywhere at 2 points during the session. So if you have a cell phone nearby, you can interact that way, or if you're on a computer, you can just open a new tab and we'll step through that when we get there. And the third thing here is just a brief agenda of what we'll be doing today in our hour. So I have some interest approach ideas for how to introduce hydroponics as a classroom activity. We're going to do an abbreviated lesson on the ag lab that we call No Soil Now What. And then for our older students, I have some more ideas about how to use inquiry-based learning and hydroponics together. And we'll end with some sharing and of course more questions. So the first question I'm going to pose to you is, how would you grow your food in these places? And I'd like you to use the chat to answer this question. You can see these pictures are either really remote areas or maybe areas where food would be hard to grow. So go ahead and type in the chat. Oops, did my slide just change? Cassidy, it doesn't look like I'm able to see the chat while I'm sharing, so maybe you could read some responses.
So far we have greenhouse, container gardens, hydroponics, green roofs, raised beds, container gardens, heat lamps, grow lights, controlled environments in the buildings, rooftop gardens, hanging gardens.
All right. Yeah, those are all really great answers. And if you registered for this session, you know that hydroponics is also a great answer. And we're going to talk more about how we can grow food without soil and in these remote areas using hydroponics. So I thought first I would start with a real world application of hydroponics, because if there's anything teachers or informal educators or even volunteers know, it's that students will always ask, well, why do I need to know this? Or when will I use this in real life? So here's an example. Last December, I studied abroad in Chile for a few weeks, and we got to visit the Atacama Desert, which is nicknamed the driest place on Earth. So they get about 0.6 of an inch of rainfall all year round, so not a lot. And the temperature fluctuates anywhere between 105 during the day to 40 at night. So these growing conditions aren't good, and so these people still need to find a way to eat their food. So they do it by using hydroponics. And so we visited 2 different hydroponic farms. I'll start with this middle picture on the bottom here. This is a storage tank. So this particular farmer, and most farmers in the desert, they only get water to their water lines once a month. So this particular farmer, his day of the month was the 10th. So on the 10th at 10 a.m., he would open his faucet and his ration of water would flow from the water lines and it would fill this pit. And then he had to make that water last until the next month on the 10th, when he could again open his faucet and have water. So he found a way to filter and reuse his water using the system on the bottom left-hand corner here. And he was actually able to get this set up through a grant through the Ministry of the Environment. So that's similar to like our Department of Agriculture here in the United States. So he found that by using hydroponics, he could reuse his water and make it last longer and still grow more food, so he was able to make his business more profitable. And then the rest of the pictures you see are things that he was able to grow hydroponically. So tomatoes, some different greens, obviously lettuce and spinach are very popular too. And so he can take his finished product and harvest it, wash it, package it, and get it to the store in less than 2 days, which is pretty impressive for some of the remote areas in the desert. So now I'm going to share with you this video, and it's a part of a series called How Does It Grow? But I thought this video was unique because it's also about Pennsylvania. So you can share this video with your students as a way to introduce hydroponics, and we'll watch a little bit of it now.
It's the dead of winter here in Pennsylvania, and I'm on the hunt for one of the most nutrient-packed foods on the planet. The earth is frozen, daylight is short, not good conditions for growing any vegetable, but I found a place where this one grows year-round, so I'm dying to find out. Spinach, how does it grow? This is Bright Farms, literally the size of a football field. This greenhouse pumps out 75,000 pounds of spinach a year. But here's the coolest part. They don't grow spinach in soil, they grow it in water. This kind of growing is called hydroponics. Hydro means water, ponics means work. In hydroponics, plants are grown in nutrient-enriched water that gets reused.
With record droughts and rising demand for local foods, hydroponics could be the future of farming. Although really, hydroponics is thousands of years old.
The ancient Egyptians farmed on rafts along the Nile, and the Aztecs on lakes. In the 13th century, Marco Polo marveled at the floating gardens in China. Here at Bright Farms, their spinach floats on boards over ponds filled with well water. These boards have small slits for roots to dangle through. Head farmer Jason Jackson basically plays the role of God. With a click of the mouse, he controls the heat, the moisture, the daylight, all the conditions that conventional farmers can't control. What's trickier here is perfecting the mix of nutrients he gives the plants. Without soil, there's no buffer between the delicate roots and the potent fertilizer.
If I don't get it quite right, I could potentially burn the plants, at which point we'd have to drain a pond. And today I have not had to drain a pond.
Have you killed any plants?
I have not killed any plants,
Okay.
no.
Okay, but wait, there's 40,000 gallons of water in that pond.
Yep.
And hydroponics is supposed to conserve water. How does that work?
We actually use 80% less water than outdoor conventional ag, and we do so by recirculating the water in the ponds themselves.
Not all hydroponic farms recirculate their water. Some think nothing about draining the ponds, since it's always easier to start with fresh water. But Jason likes to nurture the pond's ecosystem, so when it comes to spinach, he enlists lettuce because it helps fight spinach's worst enemy, a fungus called Pythium that can wipe out a whole crop overnight. Growing spinach hydroponically is basically a race between spinach and Pythium. Pythium spreads by little spores that swim. Swimming is not so easy in the soil, but here in the pond, it's Pythium heaven. Because lettuce is stronger against Pythium, it helps keep the Pythium population down. Which means Jason can avoid using killer chemicals like fungicides. After 14 days on the water, the leaves are still small and tender and ready to be harvested as baby spinach. One by one, each raft goes through the cutting machine. And then it's on to packaging. Bright Farms harvests, packages, and ships its spinach to stores within 24 hours. Calorie for calorie, spinach pack.
Okay, so you can see there's a lot of different topics covered in this video and a lot of different ways you can go with discussions with students. So they talked about the biological relationships between the lettuce, the spinach, and the Pythium, as well as just processing of hydroponic lettuce and how it goes through the growing process and then the food production process. So now we're going to move into our Ag Lab lesson titled No Soil, Now What? And it's a lesson adapted from Corteva that targets 3rd to 5th graders, but it covers the basic needs of plants and then how to build a hydroponic system to meet those needs of plants. So when students first come on the Ag Lab, they're in awe by our posters and just the different learning environment, and so we ask them, what is agriculture? And we'll get answers like, well, agriculture is farming. And so we ask them to elaborate on that. Well, what is farming? And they say plants and animals. And so since we're going with a plant lesson here, we'll ask them, well, what do you think plants need to grow? And we'll get answers like water, light, but eventually someone will say soil. So we'll go with it and we'll say, well, if plants need soil to grow, how much soil do you think is on Earth to grow our food? And so we ask them to make an educated guess or a hypothesis about how much of the Earth they think is soil we can grow our food. So now I'm going to have you do the same thing. So make a prediction, and you can do this. We're going to use Poll Everywhere. So if you're on a computer, you type in this web address up here, pollev.com/Nicole Geiss 814. Or if you have your phone nearby, you can text Nicole Geiss 814 to 22333, and you'll get a text back saying you've joined, and then a simple A, B, C, or D for your answer. So do you think the Earth is 3% soil that we can grow our food on, 11, 32, or 50? So take a minute to do that, and as responses come in, our graph should move if the technology works. All right, we have responses coming in. This is good. So we have about 70 participants, so I'll give it a few minutes to let all the responses come in. It looks like we keep going back and forth between 3 and 11. Which one will it be? Okay, so it looks like some responses have stopped coming in. So we're going to go with the popular vote. 11% of the earth is soil that we can grow our food on. And so now I'm going to show you, this is the lab sheet the students complete in the lab. So they would write their guess here under A, what percent of the soil they think we can grow food on, and then color in a fraction of this chart with their percentage. So then we test this hypothesis. I'm going to switch my video camera so you can see a quick demonstration. And I need to share the audio with you. Okay, so this video is going to narrate a demonstration I'm going to show you with an apple about just how much of the earth is soil that we can use.
Perhaps you've seen this demonstration before. This is planet Earth. I'm going to show you how much of it's available for farming. If we cut the apple into fourths, these 3 pieces represent Earth's ocean water, the majority of which is snow and ice and too salty to grow anything. This remaining fourth represents land. Half of this is deserts, swamps, and mountain ranges. There's a reason that you don't see tomatoes growing in the Mojave Desert. That leaves us with 1/8. If you take the 1/8 and you cut it again into 4, these 3 pieces are ground that's too rocky, too wet, too steep, or too cold to grow crops. That leaves us with 1/32 of the apple. If you take the 32nd and you remove the skin, this skin represents Earth's topsoil, the land available to the world's farmers. And 7 billion people today and 9 billion people by 2050 hope to be sustained by this tiny sliver.
So you can see there's a big difference between what we started with and what we can actually grow our food on. And so it turns out that our hypothesis was incorrect, and it's 2 to 3% of the earth that we can actually grow our food on. So the students on the ag lab, they then fill out this information on their lab sheet, which I'll show you here. So on their lab sheet under A, they have this graph, and they color the different sections. So water is the big section, then the uninhabitable section, the non-arable section, and the section we can grow our food on, they color green. And we walk them through this while defining different vocabulary words like arable, uninhabitable, topsoil, and we also show them this magnetic chart. And so as we talk about the different pieces, we take them off. So the big one is water. Then we have our uninhabitable section. So you can see under the pieces are pictures that represent places we couldn't live, places we can't grow our food, so in the city or in rocky areas. And then we take the tiny sliver off, and they can see the soil there. This is a really neat chart, and it is available in the National Ag in the Classroom store. So if you're one of our lucky gift card winners or just looking for a new resource, you can purchase that from National Ag in the Classroom. And then we come back to the scientific method, and we ask the students, well, what's the problem with having so little space to grow our food, and yet we're expected to have 9 billion people in 2050 living on the earth. So how will we feed them? Can we do it with less soil? And we talk about renewable and non-renewable resources and the fact that the soil that we have is the only soil we'll have in our lifetime because it takes so long for soil to form. So we pose the problem, can we grow plants without soil? And we start by telling them that we're going to make another hypothesis. So they fill in the section B here, and it says they will write, I think we can or cannot grow plants with or without soil because ... And then we test it by building our own hydroponic system. So I'm going to pause here for questions if there are any before we go into that portion of building our hydroponics system.
If anyone has any questions, you can go ahead and type your questions in the Q&A section.
If we don't have any
Okay.
right now, that's fine too.
Yeah, why don't you keep going, Nicole? We'll come
Okay,
back.
sure. So I'm going to show you our demonstration table. Okay, so we have our 5 needs of plants, and the first one is space. So we tell the students we're going to need a space for our plant to grow. So we start with a cup and a lid, and we also think about the vertical space the plant will eventually need to grow in. So we have a dowel rod, and we have them measure the 3-inch mark, because that's the height of our cup, so that's kind of like the starting point, and then every inch after that. So then as their plant grows, they can track how much it's growing per day, per week, per month, however long they choose to keep it. So we have a space where our plant can grow, but we need a space for our seed too. So on the lab, we use Rockwool, which is common in hydroponic systems. It kind of is like, feels like insulation, but it's made from molten rocks. And so I'll wet it a little bit here in my cup of water. And I'm going to put it through the lid, half on top and half on the bottom. It's going to act as a wick that pulls the water from the bottom up to where our seeds sit. So they sit right inside on top. So we have our first need of plants, space. The second need our plants have is nutrients. And so we have a chart we share with the students on the Ag Lab. But first I'm going to share with you some slides from Nutrients for Life. They have some pretty cool posters that you can download or purchase in your classroom. And they deal with the nutrient cycles. So the first cycle we're going to talk about is the nitrogen cycle, which nitrogen is abundant as a gas in our atmosphere, but nitrogen as a gas is not usable by plants. So they use it as a nitrate or ammonium. So they have to convert it through different processes. And this chart explains those processes and then how the plants use nitrogen, usually to build amino acids or proteins and produce chlorophyll. We also have the phosphorus cycle. So plants receive phosphorus through crop residue, manure applications, fertilizer applications, and then they use it for DNA replication, lipids, and phospholipid production. And of the last cycle we have is our potassium cycle, which plants get potassium in the same ways as they get phosphorus, so crop residue, fertilizer, and manure applications. But they use it more for enzyme activations of chemical reactions and regulating water. And they do that, which is the potassium ion is the usable form of potassium, which is exchanged through the soil. So on the Ag Lab, we tell the students that nutrients are like vitamins, or the fertilizer and nutrients are like vitamins for the soil. So if you're sick, you might take some vitamin C because you're lacking that vitamin. Same thing in the soil. If it's lacking nitrogen, we're going to give it some more in the form of fertilizer. So to represent the nutrients on the Ag Lab, we use Orbeez, which are like little water beads. You can see those. There went my green one. And these are symbolic of the nutrients because you can't see them in the fertilizer, so this just helps students understand that we're adding the nutrients our plants need to grow. So now I'm going to give you guys a test on your nutrients. See if we can guess which one is which. You can see this on the camera there. Okay, so I have 3 different nutrients, and I'm going to show you a picture of a plant that is lacking that nutrient and tell you what plants use it for. And then I would like for you in the chat to guess which nutrient that might be. So our first nutrient keeps plants green and healthy and prevents them from turning yellow. So a plant that lacks this nutrient might look something like this. This is a picture of a plant with some really yellow leaves. Okay, so now I can see the chat. Yeah, we have some correct answers coming in. So this nutrient is nitrogen, which we added to our hydroponic system in the form of a green Orbe. Awesome. So our next nutrient helps build strong roots and helps make flowers and fruits. So here is a picture of a well-developed root system. Which nutrient do you think this is? You guys are spot on. This one is phosphorus. So I'll add that to our chart over here. And there's only one nutrient left, but this one helps fight disease and keeps plants healthy. So here's a picture of a plant lacking this nutrient. It has some brown on its leaves. Yep, this one is potassium. So you guys do know your nutrients, that's great. The last part of this chart is the abbreviations. So we talk to students on the Ag Lab about scientific notation and abbreviations for these nutrients. A lot like they might say LOL in a text instead of typing laugh out loud, or have a nickname if their name is Michael and they go by Mike. This is a shorthand way of saying nitrogen by using an N, phosphorus by using a P, and potassium by using a K. Great. So I'm coming back to our hydroponic system. We have our space for our plants to grow. We added our nutrients, which are represented by the 3 different color Orbeez. Now plants need water, the third need of plants. So we're gonna add some water. This is a fertilizer mix. We add 1 teaspoon of our fertilizer that we have here in the office to 1 gallon of water. And so we fill our cup up pretty close to the top because we want our Rockwool to touch it. And put the lid on. So now our Rockwool is beneath the water. And so it's gonna pull the water up to the seeds that sit on top. And so they'll be able to get water. Our next need of plants is air. And so in a pre-COVID world, believe this or not, we work in partners on the Ag Lab and we share materials. But we have 2 partners. They get 2 different colored straws and they are pre-drilled holes in the lid. So they just slide right in. And what we have the students do is blow into the straw to aerate their hydroponic system. We have them practice before, so breathe in, blow, take the straw out of your mouth, and inhale. And then we have them aerate their hydroponic system. And I'm not gonna blow bubbles on camera for you guys, but that's what we would do on the Ag Lab, 3 times each partner. And then we get to our last need of plants, which is light. So plants need light, and we talk to the students about where they might sit their system when they go home or back into the classroom, and we say a window's a good spot, maybe outside. But then we talk about what happens when there's too much light, and so we ask them if they've seen maybe a pond that has some scum growing on top of it, and so we can prevent that in our hydroponic system by using this blue strip of paper that we tape to the outside. And this just keeps the light out and keeps things from growing in here, because we will have these for a long time if we're going to see something grow. And sometimes this takes more than one person to get it in. It's not a perfect fit, but it'll end up looking something like this. And then we add our little measuring dowel rod here. So this is eventually what students will leave the ag lab with. However, if they take it home with them and they watch it grow or leave it in the classroom, this is one that I started about 3 weeks ago. So you can see it grows and it wraps around the dowel rod, and I'm getting pretty close to 11 inches tall up here. So there is a section on the lab sheet for the students to draw how much their plant has grown, but there are so many extensions you could do with this activity. Have the students graph the growth, have them calculate the rate of growth, and those sorts of things. So I'm going to show you that lab sheet I just mentioned.
Nicole, what kind of plant was that?
That was a pea plant. On the Ag Lab, students have the choice of a pea or a bean. I chose pea for this demonstration. So here is the last section of the lab sheet. So students in the lab, they draw what it looks like on day one. In a week, they can draw how tall it is. And then on the second week, how much more it's grown. And they fill in the blank here. So today I planted a pea seed. So if you're not familiar with our Ag Lab program, I'm going to give you a very quick rundown of what we offer on our 40-foot trailer that has all the goodies inside of it, air conditioning and everything. We offer K through 8 ag literacy and STEM lessons that range anywhere from 30 to 50 minutes, depending on which one you choose. And we cover a variety of topics like dairy, biodegradable plastic, plants, and the everyday uses of soybeans. All of our lessons meet the Pennsylvania Department of Education standards, and many schools say that they incorporate us into their curriculum to meet their science standards for that year, and so a lot of our schools are repeat customers. And you can find out more information about us at this website, which will be provided in the resource sheet tomorrow if you're interested. So I'll pause for questions. Cassidy, if we have any.
We have a couple.
Okay.
If we use hydroponics, how much of the earth can be used to grow plants?
So I would think almost all of the earth could be used to grow hydroponic plants, because they can be anywhere, simple as like a desktop setup, or like even on boats you could have hydroponic systems in the oceans and things like that. So a lot of the earth could be used to grow plants hydroponically.
If anyone else has some questions, go ahead and type them in. We have one about if there's a Ag Ed Science Lab in Houston, and you can contact the Texas Farm Bureau. They have a contact it's pretty similar, that you can possibly use. Many states have similar organizations. Mobile lab program. Nicole, where can Rockwool be purchased?
So I'm assuming you can get that on Amazon, because you can get anything on Amazon. now. But yeah, I don't know. I would have to ask our ag lab coordinator and get back to you guys on that one. But certainly online, I think would be a good option. Maybe your local hardware store, since it is very common in hydroponic systems.
I think that's all we have from now. Yeah, someone said Amazon, definitely.
Yeah. Okay,
right.
so we'll keep rocking and rolling. Okay, so you say, Nicole, this is really great, but I don't teach elementary school. I am a high school teacher, so how can I incorporate hydroponics in my classroom? And so this is one idea that we've been talking about in the office. So the soda bottle hydroponic system is also very popular. And so one activity you could do with your students is give them a variety of supplies, like paper towels, cotton balls, a t-shirt, obviously a soda bottle, some seeds and water, and then see what they come up with. Give them free reign to design a system however they would like. And you could even up the ante a little bit with that activity and assign a price to each of these building materials, and then who can build the cheapest system but achieve the most growth could be another spin on that activity. And so here are 3 variations of the soda bottle hydroponics activity. So the first one is very similar to the one I just built with you. It has, looks like a paper towel as the wick. So that pulls the water from the bottom up to the top where the plant is growing. The one in the middle is a more sophisticated system, probably where the water is being cycled through and reused throughout the day. And then the last one is a take on vertical farming, which is a completely other discussion you could have with your students, utilizing vertical space too for farming. And so here are some even more ideas that you can do hydroponics in a glove. So each fingertip has a cotton ball and a seed, and then you blow some air into the glove and tie it or use a twist tie. But you could also experiment with this version. And so maybe the thumb doesn't get any light and the pointer finger doesn't get any water. And one finger serves as your control, and maybe one finger you give as like student choice, test a variable of your choice. And then the same thing can be replicated in test tubes. If that's what you have available to you. I see my picture isn't showing up there. But same idea as with the glove, you can test the different variables in the different test tubes, see which grows the most, see which grows the least. And so when I was looking for these inquiry-based activities, I came across a really good article about how to design these activities that will be shared with, the whole article will be shared with you tomorrow in the follow-up email, so you can read that on your own time. But basically it comes down to creating an experience that focuses on connections and really takes a deep dive into those student questions. So those are always just really good things to keep in mind when designing hydroponic activity or any activity in general. So those were some ideas for older students, and you say, Nicole, that's really great, but I don't teach science, I teach history. So how can I use hydroponics? Well, we have something for you too. So here are some ideas that I broke down by subject. So we'll start with biology, that's the most obvious. You can talk about photosynthesis, pH, the different parts of a plant, root development, the light spectrum and how we utilize different sections of it, and which is the most important to plants, which is harmful to plants. We talked about the cycling of nutrients, and then of course capillary action is also applicable. In chemistry, we can talk about calculating parts per million, how the nutrients interact, pH, mixing chemical solutions like the fertilizer and the water. In history, our video mentioned that hydroponics is not a new idea, and it was used by a lot of ancient civilizations. We could also do some research into engineers and leaders that really brought this idea of hydroponics to the popularity that it is now. Oops. In math, we can calculate our cost of production, maybe start a little class business, sell the lettuce or spinach that you grow to the school cafeteria. What does it take to, what are the costs to running a business? How do we maximize our profits? And of course, graphing is a big part of that. In geography, so we can talk about hydroponics in different parts of the world. I gave one example of my trip to Chile, but there are many other countries that are using hydroponics. And how does that compare to the United States? How is it similar or different? And this is also really great for physics teachers. We can engineer our own hydroponic system using ebb and flow, and again, talking about capillary action. And I also wanted to mention that careers are a really big part of hydroponics too. And so we can throw careers into any subject we teach. Here are just 3 ideas. So if you're interested in hydroponics, you could have a career as a water chemist, an engineer, or even a grower, producer. And so I have this flag here next to this Ag and Food Careers website, which will be a new updated website will be launching on July 29th. And this is actually another project I'm working on as a part of my internship. But this website is going to be really valuable to educators because it's going to have, once it's updated, over 60 videos from industry professionals asking them what their interests were in high school, why that led them to their career in ag and food, and different ways they were able to be successful based on their interests. There's also, we're adding a completely new Educators Resources tab. So that's going to include a lesson bank. It's going to include web scavenger hunts you can use with your students. And I bring this up because there's an entire section devoted to plant science. So that's how that relates to our discussion on hydroponics. So feel free to use that website. Once it's updated, it's going to be a really great resource, and hopefully you can tie it back to your lesson in hydroponics and maybe other lessons too. So this is the last pause for questions before we do our concluding activity. Cassidy, I'm not sure if any came in yet.
We do have a couple. How do you aerate the soda bottle hydroponic garden?
So that's not an activity that I've done, but I'm sure there are some really cool engineering tactics you could use, maybe putting a hole in the side of the bottle. That would definitely take some creativity, but see if your students find an answer to that question. I bet they would come up with a lot of different ones.
Yeah, I'm sure there's a lot of ways. What is the best fertilizer to use for the experimental hydroponic system?
So the best fertilizer really depends on just what is available to you. I'm not sure of the exact nutrient ratio that we use here on the Ag Lab, but I know the name of our fertilizer is Maxi Grow. It comes in a green bag, and it seems to be working really well for us.
We also have some people, saying air pumps. Any other questions? Make sure to get them in now.
Are we good on questions now, Cassidy?
Just double checking.
Okay, sure.
One does say, is Maxi Flow the only fertilizer you use for the solution?
Maxi Grow, G-R-O-W. Yep, so that's what we use on the Ag Lab.
We also have some information that the ratio is a 10-5-14 fertilizer.
Awesome. I know we had some Ag Lab teachers on our webinar, so that was probably one of them. Thank you.
That looks like all of our, oh, we have a question. What does Phonics mean in the word hydroponics?
Yeah, so that was in our first video, the How Does It Grow video. Hydro meaning water, ponics meaning work.
Can hydroponically grown plants be organic?
I would say so if you're not using any of those pesticides or herbicides to kill weeds, because that's one of the benefits of growing plants hydroponically is there aren't weeds.
Have you tried growing tree crops using hydroponics?
I have not, but that would be interesting. We would definitely need a bigger space and structure.
Yeah, definitely. That could be interesting. It looks like that might be all of our questions.
Sure. And if any more come in the last few minutes, I'm definitely willing to stick around. But we'll move into our concluding activity here, which is another poll everywhere. Again, same thing, but this time I would love to know how you're going to take the information from today and use it in your classroom. So let me get this started here. Make sure our other one is locked down. Okay. So you should be able to type your responses in. When you respond, you can use a sentence, a phrase, and they'll pop up on the screen in bubbles. Again, texting or the website will work. Awesome. So a homeschooling plant unit. Use a 3D printer. Have the ag lab, we'd love to see that. These are great responses, keep them coming. A hydroponics chart in the classroom. Okay, so math using rate of growth for hydroponics versus traditional growing. That'll be really interesting. A farmer in Chile talked to me about that, and he can grow more hydroponically with less resources, so that's awesome. Compare hydroponics to aquaculture. That'll also be very cool. Encourage PJAS experiments. That sounds fun.
We have some in the chat box to use inquiry-based learning, develop their own, students develop their own ideas, grow different seeds like avocados, potatoes, and water in different places. Create hydroponics growers for showcase that have been
Nice.
invited to next week.
I see a response that says, we were planning this activity before COVID, but we talked about a lot of ways we could adapt this if students are at home. So likely they have a Ziploc bag and maybe a soda bottle, and they could do a little experiment at home too if they had some of those basic materials. Awesome. These are really great responses. I'm glad you guys were able to take something from this presentation. And so lastly, this is my final slide. I'd just like to say thank you for tuning in. Anything you saw with that red flag is coming to you in an email tomorrow, so be on the lookout. As Cassidy said, take the post survey. I would love to see some of you win a gift card, maybe purchase an Apple chart for your classroom. That would be cool. And just have fun and do these amazing things in your classroom. I'd love to connect with you. My email is here, and my all things educational Twitter from Penn State. So if you want to keep in touch and see what I'm up to, I would love to share more resources with you, see what you're doing in your classroom, how things worked, what didn't work. and continue just growing things hydroponically or talking about ag literacy in general. So thank you. And Cassidy, if there's any questions, we can take those now too.
We did have one before. If you have ever incorporated fish into a hydroponics growing system, like an aquaponics system.
Right, yeah, when we add the fish, that no longer makes it hydroponic, but aquaponic. And I have not personally done that, but the school I'm planning to student teach at in the spring, fingers crossed, they do aquaponics and they have a system where they use goldfish. So I'm really excited to learn more and hopefully experiment with that with my students. Anything else, Cassidy?
It looks like that's it. We have some comments. Some people have used, you can use betta fish in soda bottles, tilapia and lettuce in the same system. Someone has an aquaponics cart at school. Koi and ornamentals. Doesn't look like we have any questions though.
Sure. Your comment about the cart reminded me that on that resources sheet that's coming out tomorrow, I did include some websites to hydroponic carts that I found, but also I included an entire section on grants. So if you're looking to do this in your classroom, but maybe don't have the funding, there is a section of grants you could apply for to make this free or cheaper. Because I know teachers and educators are always strapped for cash. But also on there too is the Alaska Ag in the Classroom link, and they have an entire curriculum for hydroponics. So there are more resources than just what I shared today, and so definitely check that out tomorrow when you get that email.
It looks like that may be it. So thank you so much, Nicole.
Yeah, thank you.
Thank you, everybody. Make sure to do your post-test. Again, you can, if you completed the pre-test and the next post-test and more sessions, you can get more entries into winning a gift card to the online stores for some resources. And we hope to see you at a future session. The post-test link is in the chat box, and it should also pop up. Okay, thank you everybody. We will see you next time.